the distribution like this. So you don't have to have necessary to calculate by hand. There's a graph can be useful. If the shift is 1.0, it's right here, 1 sigma and sample size is n. So there's a different size. If the n is equal to this, and it can be detected. And this is a k. This is the shift. It's the 2.0. This is a 2.0 right here, and you can check. And the beta is the type 2 error in here. So X bar chart for the 3 sigma, the beta equal to the p is the distribution. In here. The vertical is the type 2 error, and horizontal axis is k. The k sigma detecting shift, how many standard deviation. So you can directly check this graph to determine what is the beta. Okay, then talk about the ARL, the expected number of samples taken before the shift is detected, simply average roundness. Then, okay, talk about the alpha. In control. When process in control, then what is the ARL in? The ARL stands for the average roundness. So if the ARL equal to 1, ARL in equal to 1, that's probability. ARL in equal to 1. So that is equal to the first one. There's a signal out of there's a point. There's a point for out of the control limit. So the probability is equal to alpha. So n that means in control. So there's a sample point for within the control limit. Then the probability is equal to alpha. If ARL n equal to 2, then probability so that means the first point within the limit. Okay. So the alpha is false alarm. Or this is a false positive. Right. Then if the ARL is equal to first one, now there are no signal. So this is 1 minus alpha. The second, there's a signal out of control. So the ARL in equal to k. So probability ARL in equal to k. That's equal to the first k minus 1 in control. And the case out of control. No, this is still in control. That means within the limit. The case 1 falls outside the control limit. So probability is alpha. So like this. So we're going to calculate the average roundness. No, this is not A. This is roundness only. So roundness equal to that. So I'd like to take the average roundness. This is for example. most important, the average run length, the I equals to 1 to infinity I times probability of the, I'm sorry, not A, wrong length, not A, it's only run length, I'm sorry, okay, so the run length equal to I. So the I times run length equal to I, there's an expected value. So this is a probability times the random variable, like the expected value x equal to the summation, the x times f of x, right? So this is x times f of x, the same, the expected value of that random variable. This is random variable. Okay, that's equal to I, the first one, 1 times alpha, plus 2 times 1 minus alpha, raise the power 1, and times 3, 1 minus alpha, raise the power 2, times alpha, plus the 4, 1 minus alpha, 3 alpha, right? And it goes to infinity. What? 减1什么？ Oh yeah, thank you, good, very good. Yeah, 两题谢谢 Thank you, very good.
都是刚才的写的精彩笔记。
你有几点钟睡？说。啊？你看球赛的？啊，那可以。
体量大家都是过来的，然后今天还有，今天还要咱们再奋战一波。
当然是法国，没什么好看啊，没打就知道谁赢啊。
摩洛哥应该不会进吧？
没有，摩洛哥也很强，
防守很强，
也很强，但是
人家赔率很高。
不会。上次买他嘛。
对啊。我摩洛哥那真的是。
他们之前有进吗？这样
没有，他是非洲，他没有进过，非洲进过最后的就是科麦隆嘛，很强。然后塞内加尔有没有进过我不知道，
好像没什么印象。
然后其实这次分布的非常好，西欧一个国家，东欧一个国家，非洲一个国家，美洲一个国家。
我这是刚好分配的，
也非常好，非常好，这个赌盘也分配得很好。对。
艾老师，你有买运彩吗？
没有啊，这整天都
这可以统计。
太小金额了。
不是这里痛那里痛，心情就不太好，那一定不会中，不会中。
知道吗？
跟我一台。
没有，我想说，
没钱买运彩。
我这一辈子我最希望就干几件事，4大赛，网球的4大赛，现场看1场。
哇，真的要。
然后我 F1 也看过了。
F1 看过了。
对啊，我在上海啊，我上海看过，上赛道。那我还想去英国的那银石赛道再没有，最重要的是摩纳哥的大奖赛，他就坐在游艇上看。
哦。
大概一个人要50万台币。
旁边会有小姐的吧？
没有啦，这个。
但不止50万台币。
啊。
那就坐在游艇上面。然后还有4大赛，还有另外一个网球要看，还有一个叫高尔夫球4大赛，想去看一次，不过这很难。
高尔夫
球是要怎么看？
对啊，要怎么看？
买票进去，他就跟着走。
就是说跟着他打完球，然后你
不是你就跟着走。
你说后面。
他会有拉绳子，你要在绳子外面。
哦。
跟着走。
然后世界杯足球赛太难，因为我们自己国家就没办法。去加油帮日本、韩国又不爽，不要。
确实。
Okay, so this can be represented. Yeah, how then, gentlemen, that we factor out alpha. So you're from Paraguay. How about the Paraguay football team? Have you just advanced to the second round of the World Cup before? I think they do.
Yes, in 2010 they was the semifinal.
Semifinal?
No, quarter.
Quarter final. 前八强，你看到没有？尊重人家国家。前八强，厉害。我们们是不是要踢会外赛嘛？
我们还赶快抢外。
亚洲有几个名额啊？
今年有4个吧？
澳洲有没有？
有
有嘛？
那5个。
澳洲有进嘛？对不对？
有啊，伊朗、澳洲。
不要说什么连越南都踢不过，你中国大陆输越南啊，我们也不一定会输，我们也不会赢中国大陆啊，我们连香港都踢不赢，对不对？香港都踢不赢。
可能我们国家不含那个。
不是啊，我们不是很多小孩子都在隔壁就踢来踢去吗？
是吗？真的假的？
有很多啊，很多啊，超多的。OK，back to
但
it。
是
球现在
电视人看太多了。等我们哪天开始画漫画就有。
因为每个人的头锤都有100万吨。自己演那么久，还会这招。
Okay，back to here. James, last. So factor out alpha. We factor out alpha, then there's an infinite series. Am I correct? Then I would like to remind you there's a Maclaurin series. Maclaurin series as long as the actual value of x is less than 1.0. That means this value between 1.0 and minus 1.0, it can be represented. So infinite series. So as long as the x is within 1 and minus 1, the series converges. What converges? That means when the x raised the power to really big, like the x raised the power 100, that value is going to be decreasing, like this. So it is a positive, so it's a decreasing like this. If the x is negative, it will decreasing like this. Alternating positive, negative, positive, negative, positive, negative. This is 1, there's a power. The first spike going to negative, positive, negative, positive, and like a damping, and it decreasing. If the x between 1 and minus 1, right? So, then based upon this, do you have any implication or a hint related to this? This is 2, this is 1, this is 3, 2. Then we can, this is pretty much like that. Then we take the first derivative. We can take first derivative, partial derivative. This is calculus. So that is, this is 0 plus 1 plus the 2x plus the 3x squared plus the 4x3. This is pretty much like the form of this one we would like to have. Can you recognize this? When we take the first derivative of the Maclaurin series, exactly get the same form of that. You just treat the 1 minus alpha, 1 minus alpha, 1 and x. 1 plus 2x plus 3x squared. 3x squared plus 4x cubic. Am I correct? Yes, done. So what is this? So this is 1 minus x. Minus 1, since this is reciprocal. No, I'm sorry. Reciprocal, minus 1. And then take the derivative. So that is equal to the minus 1. The coefficient of the power, minus 1, multiply inside, in front, and then reduce the exponent by 1. And then also chain rule. 1 minus x. This chain rule. First derivative minus 1. So that is equal to the 1 minus 1 over 1 minus square. Am I correct? Patricia, are you doing okay?线，你 OK 吗？线？哎，你叫什么名字？线加加线。
你说我吗？
啊，对，
我要现加。
线加，我一个线。Yeah.
线
Are you okay doing with this?
线了，
想一下。
OK, OK. 你姓廖对不对？赖，
他姓赖，
赖，还有
我拿的
郑，CH 那个郑国的郑，
郑成功的郑。
郑成功，也是忠良之后。Get them.
沦落。
是阴险一个。
So this is alpha, right? So this series can be represented by this 1 minus x squared over 1. 1 minus, what is the x in here? What is the x in here? 1 minus x. Okay, 1 minus alpha. Am I correct? This is 1 minus x, x is 1 minus alpha. So this is alpha. Question? So finally we derive. Done with the right equal to 1. As long as the process is in control. If the process is in control, that is equal to 1 divided by alpha. So Yang-Ting, so we expect the ARL in as long as possible or as short as possible. No, why? Since the process is already in control, we do not get some trouble. So process control, just let it be alone. So be it. We don't want to intervene, so we expect the ARL in as large as possible. Since we expect it as large as possible, so we like the alpha as small as possible. Okay. Question? Any questions so far? 快点抄，快点。来，请帮我擦了。这样，还没写完，请举手。好，等一下，哎。牛，你写完没有？来，就帮我擦了，快点。哎，牛，你怎么穿其他颜色衣服啊？你是什么毛病啊？人生那么晦暗。黑白郎君。
穿久了就变黑色。
他说脸上看不到的。
什么？你说什么？
没有，他说那个口罩看起来像鸭子，很像吗？很像啊，是蛮像的。你看那黄色的话就更像。
Okay, so for this example, in general, expect numbers sample taken before the ship is detected single average roundness. Okay, well, expect the number detect single average roundness. So this is ARL out. We like to derive ARL out as well. So process in control ARL in is equal to 1 over alpha. How about when the process is out of control? What is the ARL?
我前面在讨论 in， 后面讨论 out。
高级，教堂锅。
要听。When run length equal to 1, when process is out of control, what is the probability equal to 1? Out of control. No, probability. Probability. That means, yes, we do not commit typing error. We detect it. That's the power, right? Now, when run is equal to 2, when process is out of control. So it is infinite series as well. The same idea. Then the ARL out equal to the I starting 1 to infinity. So this is I times the probability. Of this. RL equal to I. That is I starting 1 goes to infinity. This is I 1 times beta I minus 1 and 1 minus beta. Is that correct? Yes. So that is to say that is equal to the 1 times 1 minus beta plus 2 times beta 1 minus beta plus 3 beta squared 1 minus beta and goes to infinity. This is also another Maclaurin series. We factored out 1 minus beta. That is 1 plus the 2 beta plus the 3 beta squared plus the 4 beta cubic and so on and so forth. Am I right? So, yes, then this is 1 minus beta. It can be represented the same series. This is 1 minus xx is the beta squared. So finally turn off 1 minus beta. So this is the answer which can be derived. Monji. Question? Gentlemen, any question? So, therefore, in our example, the beta is 0.25. If look at this, n equal to 5, n equal to 5, and there's a delta equal to 1.0, then which can be n equal to 5, 1.0,
这里面热水，
n equal to 5, n equal to 5 here, and 1.0.
来小番茄，
If you check this graph, n equal to 5, 1.0. So 1 minus beta, the beta is about 0.8, right? 0.8, 0.75 or 0.8. So this is 75, so 1 minus beta about 0.25, average 4. 4. The average 4 runs. So in other words, expected number sample taken to detect a shift is about 4. So every 4 sample are taken, then the shift can be detected. So, Yang, then for the ARL, are we expect it is a large or small? Small. So we expect it is small. Then we like to detect the shift as early as possible. So we expect it as small as possible. If this is really small, close to 0, cannot detect the type 0, then close to 1, the first sample can be, the sample uses to detect the shift. Okay, done. Keep going. So this is sample, so finally, the ARL known is ARL in. ARL1 corresponding to ARL out. Okay, let me say it again. ARL known in the textbook indicates in. 1 indicates out. Okay. So like that, I mentioned this is H. Other performance measure based on ARL center of interest. So this is average time to signal. Average time to signal. H is how long you take the sample. Then the N tag times ARL. I is so say it might also useful to express the ARL in terms of the expected number of the individual unit. For example, every time each sample we take the 5 observation. How many observations are taken? So this is ARL times L. So there's 2 different measures. How long? Every 1 hour, every 30 minutes, or every 2 hours, take 1 sample. So how long we need to wait until the shift can be detected. Second, how many observations should be taken? That means this is the ARL times the sample size. This is equation 6.23. Okay, this is the graph. So you don't have to calculate it. No. So you can use this to get the average run rate. So you don't use that. However, it's not that useful, so the hand calculation is quite convenient. Okay, control chart for X, Y, and S. Page 242. 242.
他推荐一个好表，
什么？
说中山要吃啥？
中餐哦，那个光华有一家很好吃啊，
哎呦，
那个就是什么
烧腊，
烧腊啊，超爱，就是卖那个什么玫瑰叉烧、山鸡叉烧，那个
火
在
云邪
可
神
不可的对面，它涨价，它比较贵，变少，饭可以加吗？他们加辣萝卜干要加多加5块。
让他加了20块，
没有吧？
他现在涨价了，
多少钱？那个3宝一个多少？110。
原本
他现
120，
在随便都就是原价都涨了，
真的假的？涨那么多？
我那家就是我觉得蛮好吃，但是就对我来讲太咸。我这个年纪大，吃那么咸不好，那肾不好。
拿一锅水这样泡。
OK， 这样子吧。
你都这样吃？
少油少盐。
Contribution for X bar and S. So sometimes, like, so if the sample size is quite small, then 对，我们还有休息，我要分3段路。
好，对，从整间走起。